Perpendicular lines are lines that intersect at 90-degree angles. Like these are perpendicular lines. And what we're going to be doing is we're going to be looking for equations of lines that are perpendicular to other lines. And it's going to be almost the same as finding equations of lines that are parallel to each other, where we had parallel lines that had equal slopes. The slopes, as you can see, of perpendicular lines are not equal. So here, let's say this slope is m. The slope of a line that's perpendicular to this one is the negative reciprocal of the original line. And actually there are a few ways of remembering it. One way is the negative reciprocal of the original line. Another way is m1 times m2 is equal to negative 1. That means the slope of the first line times the slope of the second line is equal to minus 1. Another way for people who like remembering slope as rise over run is substituting rise over run in for m1. So we get this is minus sign, rise over run, and then this fraction flips. So m is equal to negative run over rise. So there are a lot of different ways of remembering it. Just pick whichever way is easiest for you. I don't really have any special recommendations. So let's say we want to find the equation of a line that's perpendicular to another one. Let's say we have y is equal to, let's do something simple, 2x. So y is equal to 2x. Perpendicular lines are the same, except the slope is the negative reciprocal of the original slope. So to find a line that's equal to this, and for right now we're just going to do any line. Any line, doesn't matter. So obviously there's an infinite number of lines. I mean, a line can be perpendicular here, perpendicular here, perpendicular here. The only difference between this line and these other lines is just the y-intercept. So it's very much like parallel lines where there are unlimited perpendicular lines. There's perpendicular lines over here, 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 forever and ever. So let's not worry about the y-intercept for now. Oh, there we are. So let's not worry about the y-intercept for now. So if I want to find just any equation that's perpendicular to this line, I'm just going to do this. The slope of the perpendicular line is equal to the negative reciprocal of the original slope. And the original slope is 2. So I put in 2 in the bottom, and it's equal to minus 1/2. So one possible equation is just y is equal to negative 1/2 x. So that's how that works. It's very simple, straightforward. You just use one of the formulas that I'm not going to write them all again. They're all right up here. Any of these formulas, use this one, or this one that I drew all over. And a question you might have is, where does this exactly come from? And there are a couple of ways of showing where it comes from. There's a more mathy sort of way where we use Pythagorean theorem to prove it, and then there's the very primitive and barbaric way, which I think is easier to understand, and it's the one I'm going to do right now. Mathematicians say it's not elegant, but whatever, it's easy to understand. So here we have the coordinate axes. And as you can see, this coordinate axis, it's perpendicular. So the y-axis So the y-axis is perpendicular to the x-axis. This is a 90-degree angle. It's perpendicular. What I'm going to do, since we can't figure out what the slope of the y-axis is because it's undefined, what I'm going to do is I'm going to turn it so it's diagonal. So let's say I turn the coordinate plane. Let's say I turn it this way. So I've just turned it. So now it's this way. And it's not, man, I hate drawing. I mean, I like it, but I suck at it. There. That's a little bit more perpendicular. So now what I'm going to do is I'm going to say I want to go down A units on the x-axis. So let's say I go down A units on the x-axis and A units on the y-axis. But what I'm going to do is I'm going to go down A units on the tilted one. So let's say I go down A units, and the A units is, let's say A units is like right here. So this is A units. And I'm going to go down an equal amount of units on the y-axis. So these two triangles, if I go down an equal amount down the y-axis and an equal amount down the x-axis, these triangles are going to be congruent. They're going to be equal. This triangle is the same size as this triangle. This side, so let me show you. This side is equal to this side. This side is equal to this side. And then this side is equal to this side. And that's going to be important. So I'm going to want to find the slope of this line. Let's say I want to know the slope of this line. This line I'm going to do in blue. This line, M. So the slope formula, to find the slope, it's y2 minus y1 over x2 minus x1. So if I want to find the slope, I need to do this side, x2 minus x1. That's what this value is. And then this up here, this is y2 minus y1. And that would give me this. This is M. This is the average rate of change. From this point to this point, it's y2 minus y1 over x2 minus x1. But if you notice, this side is equal to this side, and this side is equal to this side. So this side is equal to, let me do it in a different color. So see, since we went down A units, this side is equal to this side. I hope everyone can see that. And this side is equal to x2 minus x1. So this side right here is equal to x2 minus x1. And this side is equal to y2 minus y1. See, this side is the same as this. y2 minus y1. So now if I want to take the slope of this, it's the opposite, see, because my rise is the same as this run, and this run is the same as this rise. So if I want to take the slope of this line right here, it's equal to, well, let me write it over here. It's equal to x2 minus x1 over y2 minus y1, because this side is equivalent to this side, and this side is equivalent to this side. So I'm doing the opposite, and the only difference is this is heading into a positive direction, and this is heading into a negative direction, so I put a minus sign out here. So this is sort of a very primitive and barbaric way of explaining it, but I think it's very easy to see visually. Oh, this side is equal to this side is equal to this side. That's why this formula is like this. That's why it's equal to the run over rise, which is equal minus run over rise, which is equal just to 1 over the original slope. So I hope everyone can see that. I'm gonna do, I'll do the math explanation too. Some people like that better. It's not necessarily that I don't like it better. It's It's just sometimes when you've just started math, it's a lot easier just to see a picture than it is to see a bunch of numbers and variables thrown at you and say, oh, this times this squared, and I think this is just much easier just to see it and understand it. But I'll do the mathematical way, but I won't do it on this video. I'll post it as a response to this one. So if you want to see that, look for the response.